So a lot of folks like to claim that there's no evidence that fructose is a poison. Now, in moderate amounts, it's not. Remember, fructose is the principal sugar in, plants. So vegetables that have a minute amount of fructose, they're not deadly, okay? So what about fructose? Well, when you overconsume foods high in fructose, it can become damaging. So how high intake of fructose may trigger fatty liver disease. A study suggested that consuming high amounts of fructose may promote non-alcoholic fatty liver disease by damaging the intestinal barrier. The findings could lead to new treatment and prevention strategies for fatty liver disease. Fructose is a common type of sugar in the American diet. Okay, it's in high fructose corn syrup, but it's also in fruit. This is one of the problems I found when I switched from a moderate / low carbohydrate vegan diet that I had been on for quite a while to the starch solution, which allowed me to snack on fruit. It caused my triglycerides to go through the roof. Okay, now what was also interesting is it caused me to have IBS type symptoms, most likely because of this. So an inexpensive substitute for cane sugar that was introduced in the 1970s, it's now used to sweeten a variety of foods, including soda, candy, baked goods, and cereals. This is why, and people are going to go, but artificial sweeteners. If you enjoy soda, drink diet soda, unless you have phenylketonuria, but drink diet soda. And if you do, there's probably brands of diet soda sweetened with stevia or something like that if you want to break the bank on a bottle of soda if you like it that much, or you can probably buy a soda maker and make it your damn self. But studies have linked excess consumption of high fructose corn syrup and other added sugars, to health problems like obesity, diabetes, and heart disease. Remember, people claim that John Yudkin didn't have the science to back up what he said. That's not true. It was observationally true, and it's clinically true. When you're a physician, and I'm not a physician, I want to make sure that people understand that. I am not a doctor, I'm not a DO, I'm not an MD, I'm not a chiropractor, not a nutritionist, not a dietitian, not an LPN, not an RN, not a CNA, not anything like that, not anything like that. This is not medical advice. But what you have to understand is doctors, for example, Dr. Atkins in the Atkins Clinic in New York, he treated thousands of people, okay, and thousands of people's health improved, their triglycerides normalized and things like that. But that's the short-term effects of a ketogenic diet. Remember, the Atkins diet was not ketogenic long-term, so keep that in mind. But studies suggest that high fructose intake may increase the risk of non-alcoholic fatty liver disease, in which too much fat is stored in liver cells. Fatty liver disease can lead to liver inflammation and liver damage, resulting in a more aggressive disease called non-alcoholic steatohepatitis, or NASH. We're going to call it NASH. NASH can progress, or non-alcoholic fatty liver disease can progress to scarring of the liver, cirrhosis, liver cancer, and liver failure. Scientists have been unsure how fructose might contribute to non-alcoholic fatty liver disease. A research team led blah, 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 blah. The thing is, this is what you have to understand. Correlation does not equal causation, but when you start narrowing down other factors, okay, it kind of does. Even if you know, so that's the thing, they might not know the mechanism behind it, but they know that it does it. Okay, so the researchers randomly assigned mice to receive either high fructose diet or controlled diet with the equivalent calories from cornstarch. So you have to understand, this is starch. They're still receiving starch. They're not receiving sugar. So their body is going through the amylase process. It's going to break that starch down into sugar, but it's a different process. It's a different metabolic process. It's not directly going through the liver. Within a few months, mice on the high fructose diet developed fatty livers and had greater rates of liver tumors than mice on the controlled diet. Mice bred to be prone to develop NASH. Now, this is the problem with these. One of the problems that you have with this is they should be taking normal mice, not ones that have been bred to be, susceptible to this or that. They should take normal, healthy nut mice. I don't know why they do this, because this, in my opinion, this fouls an experiment very badly. The team found mice fed a high fructose diet for long periods showed deterioration of their intestinal barrier. The intestines are lined with a layer of tightly packed cells covered with mucus. This barrier prevents bacteria and toxins from leaking into the bloodstream. Mice fed a high fructose diet also had higher circulating levels of endotoxins. So this can cause endotoxemia, okay, which is your body poisoning itself. These toxins are released from bacteria when they die. The livers of these mice were inflamed. The team discovered that leaked endotoxins prompted immune cells called macrophages to react and increase the production of cell signaling. This is one of the reasons why a high meat diet is inflammatory, and that's because meat contains endotoxins from the bacteria in it, okay, and the bacteria's death. Restoring the mice's intestinal barrier prevented this fatty buildup in the liver. Using drugs and genetic manipulations, the team was able to stop the gut barrier deterioration. So they used gene therapy. So that means that people that have this same genetic susceptibility can be fixed with gene therapy. And also drugs. Another thing that can be done, which people might be unaware of, and I'm going to get into how the microbiome works in a little bit and how to build a healthy microbiome. But one of the things is an amino acid glutamine, which is actually known as intestinal permeability factor, is very good at decreasing the permeability of the intestines, hence its name, intestinal permeability factor. Many processed foods contain high fructose corn syrup, and most people cannot estimate how much fructose they actually consume. Okay, well, this is the thing. If you stop eating processed foods, you're going to decrease your consumption of high fructose corn syrup. When you buy ketchup, look for ketchup sweetened with sugar, not high fructose corn syrup. Or even better, one sweetened with an artificial sweetener or something like that. So this is the research, the contribution of dietary fructose to non-alcoholic fatty liver disease. This is the study that was done. This breaks it all down in the scientific jargon. It causes fructose and dysbiosis. Okay, so fructose causes the wrong bacteria to grow and the right bacteria to die off. Fructose in the gut barrier. When high fructose when high dose fructose saturates fructose clearance capacity in the ileum, the excessive fructose can enter the colon and influence the gut barrier. Okay, so your body can only process so much fructose at once. Fructose also influences the intestinal barrier by regulating ethanol metabolism. So in alcohol-fed mice that lack ethanol, blah, blah, blah. So this is actually important to understand because there are certain groups of people that cannot handle alcohol. Now, obviously, nobody can handle alcohol well necessarily, but the problem is there are certain groups of people I don't want my video to get banned, so I'm not going to mention those groups of people that lack this enzyme and cannot handle alcohol at all, and they're very prone to alcoholism. Okay, so that can be an issue, so keep that in mind. So in light alcohol drinkers between 25 and 35 years old, however, fructose reduced the duration of alcohol intoxication by 30.7% through facilitating its clearance. That's actually interesting. At the same time, dysbiosis in fructose-exposed rodents may contribute to endogenous ethanol production. So what's happening here is the dysbiosis created by fructose is causing people to make, or mice in this case, to make ethanol in their guts. Fructose metabolism and the development of NASH. Fructose, this is non-alcoholic fatty liver disease. Fructose metabolism and hepatic lipogenesis. We just went through this. This is more detailed. Fructose and liver inflammation. Fructose is believed to be an inflammatory mediator that promotes the progression of non-alcoholic fatty liver disease. Macrophage, so it overexcites your immune cells there. Dietary fructose, blah, 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 blah. Possible drug targets, glucose transporter family. Yeah, this is all, you could just not eat so much frickin' sugar, and I'm going to go through that as we move on. So this is going into how the gut shields the liver from an overabundance of, toxins. So of the toxins being produced by the bacterial whatever and whatnot, and tries to protect the liver from an overdose of fructose. So as you can see here, when large quantities of fructose reach the liver uses excess fructose to create fat. A process called lipogenesis. Eventually, people who consume too much fructose can develop non-alcoholic fatty liver disease, a condition in which too much fat is stored in the liver cells. Remember, John Yudkin also stated the role of fructose in heart disease, and it was later proved by Dr. Luscombe. Well, even though there is no definitive association between cardiovascular disease incidence and high consumption of total sugar, such as sucrose and fructose, there is, however, evidence that total sugars, added sugars, and fructose from fruit and whatnot are harmfully associated with cardiovascular mortality. Now, this goes over the introduction. So you have to understand blood vessels, blah, blah, blah. Cardiovascular disease, we already know what that is. Fructose and nutrition. Fructose, as compared to glucose, enters more slowly into the bloodstream, developing lower levels, but with higher persistence. The general intake in the Western diet is 49 grams of fructose per day, only 8 grams being from natural sources. So only 8 grams of the 49 grams. So if you simply stop eating processed foods, your intake, generally speaking, would go from 49 grams a day of fructose to 8 grams. So that's how you reduce your intake of fructose. All these people, I don't know what to do. Stop eating refined foods that are sweetened with fructose. The sources of fructose from the daily human diet are primarily caloric sweeteners, sucrose, honey, apple juice, etc. So keep that in mind. Sucrose, honey, apple juice, and other natural sweeteners. And secondly, simple sugars, from which you're not getting very much from nuts, but nuts, fruits, or vegetables for that matter, but you're not getting very much from these foods, but from nuts, fruits, or vegetables. Many fruits like plums, cherries, cranberries, if you get no sugar added, dried cranberries, you can put them in your oatmeal and things like that, but they have to be no sugar added because most cranberries have sugar added. But even with the sugar added, they still have a lower sugar than raisins, generally speaking. The recent data, but don't get the ones with sugar added. They are quite tart, but that's where the magic of artificial sweeteners comes in, which I'll talk about in a little bit. The recent data report that saturated fats lose the position of the main culprit of cardiovascular disease in favor of a high intake of carbohydrates alongside food with high glycemic index, blah, 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 blah. Okay. Fructose and cardiovascular risk. An individual's susceptibility to developing a cardiovascular event within a predefined period of time establishes his cardiovascular risk factor. Now, it's funny, my cardiovascular risk factor is extremely low, and it even was when I was having all the heart palpitations and things like that. It turned out to be a neurological issue, as I've gone over. In recent years, much emphasis has been placed on lifestyle for prevention of cardiovascular disease, because that's really the only way to prevent it. Consequently, international cardiology guidelines place lifestyle as the first line in cardiovascular disease prevention. Now, people should watch a guy named Ford Brewer. He has a thing called PrevMed, I believe is the name of his channel. Or maybe it is just Ford Brewer, but I strongly recommend people watch Ford Brewer's videos on preventative medicine. In medical terms, a healthy lifestyle corresponds to a physically active life, maintaining an average body mass index, following a balanced diet. Remember, we went over how do you extend human lifespan? You do what you already know to do, what you're being told to do by naturopathy, by allopathy, etc. Regarding fructose consumption recommendations, the American Heart Association considers the prudent upper limit of fructose consumption is 50% of the discretionary calorie allowance. I would try to keep it as low as possible. The evolution of our society has led to an involution in terms of food consumed. We distance ourselves from nature out of a desire to speed up food production and slow down food degradation. In addition to these aspects, consumer society has encouraged the improvement of food taste, which has been achieved by the addition of sweeteners. Okay. This is about studies here. This is a meta-analysis, of course. In humans, the consequences of high fructose consumption have similar effects to those in animal models, leading to non-alcoholic fatty liver disease, dyslipidemia, meaning high triglycerides, insulin resistance, meaning your body doesn't use insulin properly, and reduced resting energy expenditure, meaning your metabolism drops, and impaired postpartum fat oxidation, meaning you're not burning fat. Regarding potential mechanisms involved in increased cardiovascular risk induced by overconsumption of fructose. Okay, conclusions. Although it is known that increased consumption of added sugars is associated with a greater risk of cardiovascular disease independent of caloric intake. Meaning, even if, this is the problem you have like with that Twinkie diet. Remember the guy that went on the Twinkie diet and lost weight? Doesn't matter. If you're eating too much sugar, regardless of your overall caloric intake, you are at a greater risk of cardiovascular disease, regardless of whether your calories are low or not. Sugar consumption remains high worldwide, since high fructose intake is associated with several cardiometabolic alterations, including dyslipidemia, high triglycerides, insulin resistance. Your body's not using insulin properly, so you're going to develop this next one, diabetes, and hyperuricemia. I'm going to have to look that one up. I'm assuming that has to do with the leakage of, blood, protein or sugar into the urine, and non-alcoholic fatty liver disease. Further longitudinal studies should be conducted in order to fully elucidate the association between certain sugars like fructose and cardiovascular disease development and its progression. Okay, moving forward. So this study here, new study, links combination of fructose and glucose in high fructose corn syrup to heart disease. Okay, So consumer choices and dietary guidelines, blah, blah, blah. You can read this on your own. Bottom line, don't consume high fructose food. Harvard Health Publishing, you can read this on your own. Too much fructose, a hazard for heart health, from the Harvard Heart Letter. Fructose also has neurological effects. So, new study suggests a link between fructose and Alzheimer's disease. So you might be saying, well, why don't I just go on a ketogenic diet? Well, the problem with that is there are side effects to a ketogenic diet. So in the first half of this century, vigorous debate was waged between nutritionists advocating high carbohydrate, low fat for optimum physical performance. The thing is, you need a balanced diet. It just so happens a balanced diet does not include loads and loads and loads and loads of sugar, okay? It was fueled on the native peoples of the North Plains, Pacific Northwest, blah, 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 blah. Okay. To address the question of exercise, this is the thing. Your exercise capacity goes down with ketosis. That's well known. Okay? Because your muscles don't have the glucose. Oh, I know I'm saying glucose, but you have to remember your body builds glucose from its ingestion. Well, it disassembles glucose from the carbohydrates you're consuming. Okay, so you need that glucose for different parts of your body to work properly. Energy restriction. The majority of recent research involving caloric restriction has been the result of blah, 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 blah. Obviously, if you're not eating enough, you're going to feel like crap. Early effects of caloric deprivation. You can read this on your own. And I'm going to move on here. So you don't have to give up fruit to be enjoying, you can still enjoy fruit and not be over-consuming fructose. So, avocados and berry, okay, these are different low-sugar fruits. Avocados are very low in sugars. Berries are relatively low in sugars. Melons are relatively low in sugars, but taste amazing. Rhubarb, relatively low in sugar. So eating plenty of fruit is a great way to introduce vitamin C, potassium, fiber, folic acid into your healthy lifestyle. However, consuming fruit can lead to a sugar spike. To avoid this, it's important to have savory foods with your fruit whenever this is possible. So what this would be is, instead of having cake for dessert, try cantaloupe. Okay? So think about it that way. So you're going to have a big meal of like chili or something. So after the chili, have a little bit of fruit, a wedge of cantaloupe or something like that. What to avoid? Whichever fruit you love the most, fresh fruit will always be better, blah, blah, blah. Yeah, don't get frozen fruit or any fruit with added sugar, okay? That's not a good idea. Moving forward. So this is 11 low-sugar fruits. You're going to see some repeats here, of course. Berries are best because berries also contain phytonutrients that have anti-aging properties and a slew of other health benefits. So lemons and limes, raspberries, strawberries, blackberries, kiwis, grapefruit, avocado, watermelon, cantaloupe, oranges, peaches, okay? So takeaway, these 11 low-sugar fruits contain between 1 and 13 grams of sugar, but remember that serving size makes the difference. A serving of watermelon is just 1 cup, and eating 3 to 4 cups of watermelon can mean consuming almost as much sugar as you'd get from a can of soda. So keep that in mind. Of course, all types of fruit contain more vitamins, minerals, and fiber than sugary processed foods. They also contain phytonutrients. As I noted, watermelon is a source of lycopene. In case you're wondering, diet soda is not associated with diabetes. So, although reported consumption of diet soda and, what is this? What are they using NAS to shorten here? Let's see here. And non-caloric sweeteners, there we go, to sweeten their beverages. During an average of 8 years follow-up, they identified 98 causes of incidence of diabetes. After correction for multiple comparisons, there was no statistically significant associations of reported diet soda and, so conclusions, although reported consumption of diet soda and artificial sweeteners were high, neither were associated with diabetes risk. Please keep that in mind. It's getting really ridiculous. Like one of my favorites is, and it's sad because I actually like Dr. Lustig, but keep in mind the brain does not release insulin. Because that's one of the, if you consume artificial sweeteners, the brain will release insulin. The brain does not release insulin. The pancreas does. Extensive scientific research has demonstrated the safety of the 6 low-calorie sweeteners currently approved for use in the United States and the U.S. and Europe. Stevia, acesulfame K, aspartame, neotame, saccharin, and sucralose. If taken in acceptable quantities daily, there is some ongoing debate over whether artificial sweetener usage poses a health risk. This review article, so that's a review article. So this is what you need to understand. Artificial sweeteners and non-alcoholic fatty liver disease. There is a speculative role that by causing dysbiosis, it's speculative. There's no evidence, and I'm going to skip to the conclusion here because I don't really feel like going through this. You can go through it on your own if you'd like, but dysbiosis is one of the factors with demonstrated contribution to the pathogenesis of non-alcoholic fatty liver disease. Increasing evidence shows that artificial sweeteners have a potential role in microbiota alteration and dysbiosis. We speculate that increased consumption of artificial sweeteners can further raise the prevalence of non-alcoholic fatty liver disease. However, further human studies are needed to determine this relationship definitively. It's never been determined. Okay? Now, this is one of the problems. You got to start using a little bit of common sense. If you feed a mouse 6 years worth of artificial sweetener a day for for the duration of its life, probably something might happen to it. Okay? But that's not what's going on with people. So keep in mind that if you consume artificial sweeteners, you probably should also be consuming things like blueberries, cocoa, herbs, spices, etc. So phytonutrients modulate the composition of the gut microbiota because you want to get your phytonutrients, okay? This is the introduction. So nutrients play an essential role in maintaining the regular functions in the body. Their basic functions include providing energy, blah, 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 blah. Lipids, protein, Phytonutrients are absorbed first to alter the composition of the gut microbiota, which includes inhibiting pathogens and promoting the growth of beneficial bacteria. So it inhibits pathogens and promotes the growth of beneficial bacteria, and then to influence the production of their metabolites, which would further modify the intestinal environment by inhibiting the production of harmful compounds such as indole, lipopolysaccharide, and hydrogen sulfide. Some polyphenols, such as those found in green and black tea, may inhibit the growth of Helicobacter pylori, Listeria, and Staphylococcus, etc. Okay, and E. coli, Salmonella, blah, blah, blah. Overall, the relationship between phytonutrients and human health is established through the metabolic function of the human digestive system, mainly through the participation of gut microbiota. The gut acts as an important sensory organ capable of detecting, transmitting, integrating, and responding to signals. So clearly I'm not at all promoting a carnivore diet. In conclusion, the natural products from plants, phytonutrients have shown unique diversity and safety. Phytonutrients are involved in various physiological processes and may prevent and mitigate disease pathogenesis. Summary of factors affecting the bioavailability of phytonutrients. You can read this on your own. Catechins in the microbiota. This is something that's rich in cocoa. I'm a fan of cocoa. Or catechins are extremely abundant in polyphenol-rich green tea and its extracts. Blah, 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 blah. Okay, so it has demonstrated the health effects of catechins, including anti-inflammatory, antimicrobial, immunomodulatory, and neuroprotective effects. Bioavailability, blah, blah, blah. This is what you have to understand. Something that may not be biologically available to you or me is potentially biologically available to your microbiota, which explains why you are getting some of these health benefits, even if things aren't necessarily bioavailable to you as the organisms inside you. It helps to regulate them. You can read this on your own. I'm going to move forward. So, gut microbiota, dietary phytochemicals, and benefits to human health. This is the proposed review, findings, summary. Summary. Information obtained from these studies may provide valuable insights to guide for future clinical research for the development of therapeutics, botanicals, and drug efficacy. So I wanted to skip down to fibers real quick. We talked about phytonutrients. Whole plant foods include vegetables, whole grains, and fruits, and contain high amounts of fiber. Digestible fibers are among the major bioactive components of whole food dietary interventions and significantly change the profile of the human gut microbiota. Butyrate is a short-chain fatty acid that is commonly produced by bacteria and the formation of bacteria of the dietary fibers in the colon. This fatty acid plays several important biological roles, including as an inhibitor of histone deacetylase, an energy metabolite for the production of ATP, which is the energy currency of all cells. All of our cells, anyway. Okay. Gut microbiota and phytochemical interactions in chronic diseases. The gut microbiota, blah, 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 blah. Signature profiles are variable, dependent, gut microbiota. Cranberry extracts composed of phenolic acid, flavanols, anthocyanins, and reduced weight gain. Current challenges, funding, blah, 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 blah. There is solid evidence that gut, unlike with the artificial sweeteners where it's speculative, there is solid evidence that gut microbes play a key role in the reduction of the risk of chronic disease, and phytochemicals are interactive with them. Currently, comprehensive preclinical and clinical studies reveal that the gut microbial profiles of both healthy subjects and those suffering from chronic disease, such as irritable bowel disease, CRC, and obesity, dietary intervention seems to be a less aggressive, low risk. So intervening with a whole food plant-based diet, or simply a whole food diet, is a low risk and effective approach to prevent, treat such diseases. Understand the biology functions, blah, 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 blah. Moving forward. Remember that a carnivore diet does not contain what? It does not contain fiber. So fiber is a carbohydrate. So when you're consuming a food and you're counting carbohydrates, you subtract the dietary fiber from the total carbohydrate because it's not digested as a carbohydrate. So hunter-gatherers mainly ate fruit and wild grains to the agricultural era when crops began to be cultivated, blah, 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 blah. To better understand the intricate interplay of dietary fiber intake, okay, dietary fiber and its main types. Proper definition of dietary fiber. Dietary fiber can be obtained from diets as edible carbohydrate polymers. Okay. So, this is what you have to understand. Our hunter-gatherer ancestors ate about 100 grams of fiber per day. Okay? I probably get that a day because of how I eat. The average human being is not getting 100 grams of fiber per day. The lower than recommended, say 20 to 35 grams a day is what's recommended. In my personal, non-professional opinion, I'm not a medical professional, so this is not medical advice. The closer you get to that of a hunter-gatherer, the better. Okay? Fermentation of dietary fiber by the gut microbiota, we've already been through that, but that's what you need to understand, is fiber is imperative to a healthy gut microbiome. If you're eating a carnivore diet, you are not getting this. Moving. Impact of increasing fruits and vegetables and flavonoid intake on the human microbiome. So, what we need to keep in mind here, plant-derived dietary fiber, blah, blah, blah. The aim of this study was to assess the impact of fruit and vegetable intake on gut microbiota with an emphasis on the role of flavonoids. Okay, blah, 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 blah. Correlations of dietary components, flavonoid intake, and markers of cardiovascular disease with bacterial numbers were also performed. A significant dose, X-treatment interaction, blah, 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 independent. Additionally, they observed associations between certain bacterial populations and cardiovascular disease. Effects of fruit and vegetable consumption on the mouse microbiome. This is the introduction to the research. I'm just going to peruse this. Animals, this is talking about how they did the research. These are some of the different vegetables and fruits they used, just so you're aware. Casein, cornstarch, blah, 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 blah. That's their chow. So the vegetables they used were Chinese cabbage, tomato, cucumber, carrot, cauliflower. Fruits, that cucumber and tomato should probably be down with fruits, but who am I to judge? Apple, pear, watermelon, winter jujube, and grape were the fruits. Grouping experimental animals, yada, 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 yada. Results, determination of crude fiber content, blah, 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 blah. High fat, plus, blah, 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 blah. So, let's take a look here. Effects of fruit and vegetable on liver pathology. The liver cells in the C group, blah, 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 the nucleus, compared with the C group was improved. So it improved the alignment of the arrangement of the cells, effect of fruits and vegetables on hepatic gas. So let's go down to the conclusion. The higher the index, the higher the community diversity. So diversity is a strength in your gut microbiota. So the higher your dietary diversity, the higher your microbiota diversity. In summary, this research shows that continuous intake of a certain amount of fruits and vegetables can significantly increase in physical fitness, normalize, so it can increase your physical fitness, it can normalize liver lipid accumulation, and metabolic, and it can, of course, normalize metabolic syndrome and reduce the risk of metabolic diseases. Vitamins, the gut microbiome, and gastrointestinal health. So keep in mind, your microbiome you need to live in a symbiotic relationship with it. So the gut microbiome plays important roles in the maintenance of the host. I do recommend people read Dr. William Lee's book, Eat to Beat Disease. Diet is a key modulator of the gut microbiome. There is increasing evidence that nutrients other than fermentable fiber affect the gut microbial composition. We discussed the effects of vitamins on the gut microbiome. Some vitamins, when provided in large doses or delivered to the large intestine, have been shown to beneficially modulate the gut microbiome. So this is these are different vitamins. So remember, taking certain vitamins supplemental vitamins seems to help the microbiome. So these are A, B2, B3, C, K, and richness, vitamin D, increasing short change, blah, 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 blah. So supplemental vitamins also help with the management. You can read this on your own. This is going through the different vitamins. I'm going to go skip to the conclusion. But what you're seeing is that supplemental vitamins also help the microbiome. Go figure. Vitamins appear to modulate gastrointestinal health either through modulating the composition and metabolic activity of the gut microbiome or by affecting the normal functioning of the gut barrier and immune system. A number of studies have supplied vitamins directly to the large bowel. I guess they're doing it through the rectum, which can be achieved via overdosing to exceed, I guess you can just overtake, or by using colon-targeted delivery systems. That doesn't sound pleasant. The effects of vitamins on the host, blah, blah, blah. For example, vitamins such as B vitamins are crucial metabolism, blah, blah. Vitamin C, vitamin E, and vitamin B2 act as local antioxidants that impact the luminal reblood, blah, blah. Some vitamins, when provided in large doses or when delivered to the large intestine, have been shown to beneficially modulate the gut microbiome by increasing the abundance of presumed commensals, vitamin A, beta-carotene, B2, D, and E, increasing or maintaining microbial diversity. Vitamins A, B2, B3, C, K, and richness in D, increasing short-chain fatty acid production. Vitamin C, or increasing the abundance of K. These changes will further beneficially modulate the gut immune response or barrier and neuroendocrine function, thus influencing host health. Microbiome independently effects of vitamins such as vitamin C directly improve functioning of the gut. Okay. In addition, vitamins may impact gut microbiome composition and function via systemic effects, as several clinical and association studies suggest. For example, some of the effects of vitamin D on the gut microbiome may be related to the activation of VDR. VDR gene has been identified as a vital host factor that shapes the gut microbiome. Moving forward. So, I started with evidence of why sugar's bad. Now, what about high fat? Okay. Fatty acids from the diet and microbiota regulate energy and metabolism. Okay, we're going to skip to the conclusion. I don't feel like going through all of this. Okay, the studies in this review showing a central role of the microbiota, blah, 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 blah. Okay, explanations of metabolic disease, lipid factors, protection from obesity, yada, yada, germ-free. how insulin resistance is regulated by nutrients in the microbiota. It has been suggested that the microbiota-induced changes in the metabolism can be adaptive for the mammalian host. The general concordance between insulin sensitivity, blah, 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 blah. As suggested by the present review, the metabolic effects of dietary fats can often be predicted by their effects on the microbiome, perhaps because metabolism. They further propose that modulation of the by blocking glucose reuptake. Okay, so these are the different fats and how they affect the microbiome. Saturated fatty acids. This is palmitic acid. So they use palmitic acid and dairy fat. So this is palm oil and dairy fat. So it increased endotoxemia. Okay, insulin resistance increased. Inflammation increased. So if you're eating a lot of animal fat and a lot of saturated fat from coconut and palm oil, you are probably going to increase your risk of endotoxemia and insulin resistance and inflammation. Okay, this is omega-6 fatty acid. Okay, this increases some of these things as well. Omega-3 fatty acids reduced. Okay, and the omega-3 fatty acids were coming from fish sources. Monounsaturated, it reduced, so that's from olive oil, canola oil. What they used was oleic acid and olive oil. And butyrate and dietary fiber, decreased permeability. So it seems like dietary fiber, monounsaturated fat, and omega-3s. So canola oil is probably your best bet as a dietary oil. And I wouldn't cook it either. So when we get back, I'm not quite done with the microbiome yet. I'm going to discuss carnitine supplementation. As a vegan, I do take carnitine. So what happens is, it was thought that carnitine, which is an amino acid in meat, was causing people to develop heart disease. Now, what's interesting, carnitine doesn't seem to do that if you're following a vegan diet, interestingly enough. But we'll cover this in my next video.